So let's do operations with rational functions. So the first one we're going to do is multiplication. So if you have a multiplication problem, a regular one, where you have numbers like 2 over 3 times 7 over 4. Well, in order to do this, right, the fractions multiply together, they multiply straight across. So you get 2 times 7 over 3 times 4, and then you can simplify, right, like that. That is the exact same thing that you're going to do with functions. It doesn't matter if it's a number or if there's a function on the top, you do the exact same thing. So let's go over here. You have the multiplication of these two things. Now, you might think that you just want to multiply straight across right away. You can do that, there's nothing wrong with it. But it's actually easier if you try to factor everything that you can first so that you can see what will simplify. So the top first part, there's nothing to factor. But here you can factor out a 3. Up top, I could factor out an 8. And then on the bottom, we get m minus 10 times m plus 1 as its factors. Now, I'm not going to simplify it just yet, but what I'm going to do is I'm going to multiply them straight across so you can see what it would actually be written as. So m plus 1 times 8 times negative m plus 10 divided by 3 times m minus 5, m minus 10, m plus 1. So now, the only time you can cancel when you have fractions, right, is if the top is written as a multiplication and the bottom is written as a multiplication, because the inverse operation is the division. So now I can actually do this cancellation, which is the m plus 1 and the m plus 1. But there's actually one more, if you can't see it. It's actually these two. Okay? And what I need to do first so that you can see it is I need to pull out a minus sign from the top, or the numerator. So if I factor out a minus sign from here, you get m minus 10, because it changes the sign. And now these cancel. Okay. Now, another thing that a lot of people forget, including me, is when you cancel things, you have to write the restriction. So I actually have to write here that m cannot be negative 1, because m plus 1 equals 0 when m equals negative 1. So don't forget that restriction. Now we canceled another one, so we have to write that restriction as well. So this is equal to negative 8 divided by 3 times m minus 5 when m is not equal to negative 1 and m cannot be 10. Okay. So either like this, or you can just write a comma and split it with a 10. Split the two numbers like that. So this is the simplified version of this multiplication problem right here. Let's go ahead and do one more. So again, try to factor things out if you can right away. So the first one, there's nothing I could do, right? It's a single term, and this one is linear, so there's nothing we could do for those. So let's just write those ones out. And then let's factor the other ones. So the top is going to be x minus 9, x plus 4. And the bottom one can be factored by GCF. So we have a 3 and an x squared times x here. And to get to that one would be plus 4. Okay. So notice right away you can simplify without even doing the multiplication yet, right? The x plus 4 is cancel. And we're left with 45x squared times x minus 9 divided by x minus 9 times 3x squared. And again, as soon as you cancel something, write the restriction. X cannot be negative 4. Okay. I'll simplify it some more. X minus 9 cancels, x squareds cancel, and this 45 and the 3, does that simplify as 15? So this is actually equal to just 15. nothing else. With the restrictions that you cannot have the input value -4, I also cannot have the input value here, which is 9. And this is going to be x is 0. So those are the 3 different restrictions that we have where the output value is always 15. So what you're going to have a horizontal line at 15 with 3 different holes, one at -4, one at 9, and one